Okay, so good evening, guys. Welcome back. We will continue with our Git session. So today is Git 4 session, and today the date 17th of April. So, guys, before we start today's session, so last two sessions, right? Basically, I covered regarding the introduction to AI and also I discussed about the prompt engineering. So please go through both the sessions if you have not gone, right? It would be very much useful for all of you. Okay. And in the right, and today in the day 4 session, in today's session, we will be starting with the version control system. That is Git. We are going to start it from today onwards, actually. So all these 3 days, right? Last three sessions, we didn't discuss anything about the Git. We just had a normal discussion about the pipeline workflow, as well as we discussed about the AI and the prompt engine. These are the 3 sessions which we covered actually, right? Okay, so today we are going to start with the version control system, that is Git actually, right? So guys, before I start today's session, I just wanted to like tell you some a few of the things. Guys, please after the session completes, right? Please wait for another 10 more minutes. I want to discuss certain other aspects about our course. Okay, so we'll be discussing about that after today's session completes. Okay, that is one thing. And the second important thing which I want to inform all of you that one of the participant, I'm not taking the name actually. So he had requested me that we need to, he wanted me to take each and every session just for an hour actually. Because what he mentioned that like if I'm taking a class for like 1.5 hour or 2 hours, it becomes quite difficult for everyone to complete that whole video actually, so it will take a lot of time. So instead what he requested that like he requests me to fix the timing just for 1 hour class, so that if suppose somebody is missing the no somebody suppose somebody is not able to attend the class also, when they can easily able to go with that 1 hour session actually. So what I would restrict from now that I will try to restrict to take 1 hour class itself from now. Okay, so let me take a habit, let me cultivate the habit of taking just for 1 hour, so that people can go to the 1 hour video, like, and you can able to complete the whole 1 hour video, like whenever you want to watch it actually, right? So I know because by doing this actually we will increase our number of sessions. So instead of completing in some 10 or 12 sessions, I might take end up with taking more number of sessions. But that is okay because like because we need to if we keep it for 1 hour, right? Basically, I think people will be able to easily able to complete the all video recordings, right? Otherwise, if they've watched the video which looks like okay, it's a 2 hours video or 1.5 hour or 1 hour 45 minutes video, I think mentally, they'll not be able to manage it properly if they see that okay, the video is very lengthy actually. So I consider that as a positive comment, and I will uh, restrict myself to take for 1 hour session only. So guys, is it fine? Is this comment, whatever it was raised by one of the participants, is it fine for all of you? 1 hour class every day? Himanshu, Naveen, everyone, do you agree with this?
Yes, sir, I'm fine with 2 as well.
Yeah, see, we can take long hours. I have a habit of taking long hours, but still, but one of the participants had requested it. That's what I'm just reconsidering, about all these things, whether I should do more than 1 hour or 1 hour. So he had a valid point also. So he called me today and he told about that. So I agree with his point. So let me go with that itself. Like, let me take 1 hour class. I know it will going to prolong our sessions or prolong the number of days to complete each and every topic. I know that, but let's see how it goes actually. Okay, and guys, as I discussed, right after the session completes, like just bear for another 5 more minutes. I want to discuss few other things. So with this, what I can say one thing is that like we have to take the course for every day, Monday to Friday, or sorry, Monday to Sunday, all 7 days in a week. I have to take the classes. Then only we'll be able to complete this whole course actually. So I cannot take any break now. I have to every day, and whoever misses the session, please go to the recording. Okay. Fine, guys. So with that, let us start our today's journey in understanding or learning about what is this Git is all about actually. Okay. So today's we are going to the version control systems. Okay. Now, what is this version control system is all about actually? See, guys, consider for some time that we all are developers actually. So me, Naveen, and all the participants who are sitting right, like who are attending this session, consider we all are developers actually, and we are working on developing some application, right? Let it be something like we are developing Book My Show application, or think that we are developing some Swiggy application. So it could be any application which we are developing it. So when all of us are developing an application, so each one of us have been developing a different model of the same application. Say for example, Rajesh is a user one. User one. I might be developing the login page. Okay, login page. Whatever the login page is there, right? That feature I might be developing it. Similarly, there would be some other user like Naveen is a user too, right? He might be developing on the home page actually. It means that after you log in on the page, right? After you authenticate to the page, you when you land up with a certain page, that would be kind of a home page. So this again, it is the same application, but it is a different model actually altogether. So we both, myself, Naveen, and all the participants who are attending, right? We all are working on some of the other feature of the applications actually, right? So we might be working on all this developing all these features in our local system or in our local desktop or the laptop, right? So finally what happened, right? Each one of the user, right, each one of us whoever are developing that application, each one of us have to see the code changes whatever is done by the other person. Like user one want to see what code is been added or changed by the user two. Similarly, user two want to see all the code changes whatever is developed by the user one. So we both have to see each other's data or each other code what we have developed actually. So hence what happened that there has to be a place where we can manage or we can store all this data or all these changes, whatever is been done by the users, right, into a particular place actually. So that is what we call as a version control system. So version control system is I can say it is like a storage, or you can, to be very specific, I have to say that it is like a repository where we maintain all the code changes been done by the various developers who work on that particular project, right? Version control system. So for us to clearly understand, guys, let me open an MS Paint. Let me use some diagrams, or let me and uh, let me find some images. Okay, so this looks good actually. So this is the laptop, right? Right. Cons- right. Who is working on the? So this, so he's a user one, user two actually. Both are developers actually who are developing an application. So both of them, what they're doing, right, they are basically they are trying to work in their local laptop, and they're starting building that application actually, right? And usually what happened, right, when they have their local laptop, basically they want to at the end of the day they want to store that data, whatever they have written, right, whatever they develop the code, they want to store the data, or to be very specific, they want to push the data into some centralized storage actually, or to some centralized server actually. So I will take one more clip art, which is the virtual server. Let's see. Yeah. So this is a server, right, where they are storing the data actually, right? Now, we know that whenever we are working on any project, basically we will be creating some folder, right? We'll be creating some folder. right? Each one of us will be creating some folder. We have some folder structure actually, right? Where we have a folder structure. Yeah, I can take anything. So this is a folder structure where each one of us have the folder structure, right? Basically, and consider that the folder structure, I'm creating a folder with the name something like a project A. Project A, where we are developing the code. Similarly, even the user 2 also is developing, she has created the same folder and with the name project A. And inside the project A, she's trying to write all the code actually in her system. At the end of the day, what the user do that once he completes the code or once he completes the task of whatever he has developed it, he will try to push that changes or he'll try to push that code into your server actually, into that server basically. And here in that server also what happened, right? The same folder structure, whatever is there, right? That would be present here in this server also, right? Right. And the name would be same, like something like it is a project A, right? Right. And so this is been pushed by the user one, right, into the server actually. So consider this as something like your remote server or some centralized server where you are remotely storing all your data into this server actually, right? So once the user one, he complete a task or he writes the code at the end of the day, before he logs off, what he does that he basically pushes that code into this remote server or into this centralized server. Okay. And all the code changes, whatever he has done, right, that would be present in this server actually, right? Similarly, user 2, she will also try to work on the project, right? And she will also do a lot of code changes. And finally, what she also do, she will also try to push the code into the same centralized server. And what are the changes she has done it, that would be present in the same project A folder, right? So this is what it happens actually, right? So both of them, what they do basically, they push the code at the end of the day, right? And the code changes for both these users would be present in this remote server actually, right? So here, guys, I'm just considering just one remote server. Assume that actually in many of the organization, what they do that they will try to uh, create or they will have a replicas of the same remote server. It means that they'll have more than one instance of the same server. So it's not only one, they will have a replica of the same server like this actually, right? So why they maintain it? Because they want to maintain redundancy. It means that if suppose if this server goes down, the other server will be available. Okay, just to make it a very high availability, they'll try to have more than one server actually, right? But consider that, like in our case, we have just one server where we are maintaining the whole code actually. Okay. Now the thing is that actually, guys, now so whatever the code changes which has been done by which has been taken care by the user one, user two, and we basically we try to push it actually. So this is something we call it as a push actually. So what we call this a push. It means that from your local machine or from your local laptop, you're pushing the code into your some remote server or some centralized server. This is what we call it as a push actually. We call it as a push operation. Okay. This is something like technically we are using push operation. Okay, fine. Now assume that actually that the user one has did some code changes and he has pushed the code to this folder actually or to this remote server. Later, whatever the changes which is been done by the developer one or the user one, which is present in the centralized server, the user two wants the data. Like she want that changes code change what is done by the user one, right? So then what happened that she need to fetch that code actually, she need to fetch that code. So basically what she has to do is she has to pull that code changes what has been done by the user one into the user two system. She want to pull it actually. So that's what we call it as a pull operation. What we call it as a pull operation. So pull operation is something like where whatever the code changes which is there in the server, if you want to pull the code changes from your remote server to your local machine, that we call it as a pull operation. Or we can even call it as a fetch actually. Fetch. There's a difference between fetch and the pull. We will discuss about that later. What is fetch is all about. But consider just I'm just using a normal terminology, something like a pull, where we want to pull the changes from the server into your local machine actually. right? That we call as a pull operation, right? Say for example, this user want to pull it actually. So what she will do, that she will try to do a pull operation for this. So basically what you do, I'll just draw the diagram something like this. Okay, let me use some coloring so that she will do a pull operation like this actually. She'll pull it so that whatever the code changes which was there, right, in this project A folder, it will be readily available here under her system actually. This is what we call as a pull actually. Am I clear, sir? Right? So now, so so what this version control system does basically, it allows you to collaborate between multiple developers or between multiple users so that they can collaboratively work. They can work together on a project, right? And whenever they want to push the code changes, those code changes can be pushed to the centralized server or to the remote server, okay? And each one of the user can able to see the code changes what is being done actually, right? So that is what we meant. We call this as a version control system actually. So what is a version control system? Version control system. Version control system is a software that allows is a version control which allows. So what it does basically, guys, it allows to collaborate among the users to push their changes and get the changes done by others, right? Like, like for example, assume that like we started working on this project, right? And today is day 17, right? Today is 17th November. Assume that we started this project on 7th of November, right? So our day one uh, project was on 7th of November, 7th November, right? Right? Now consider that this user one, the user one, right? What the user one has did on the day one. So user one has did some kind of an implementation actually. What is an implementation? He started doing an implementation of or implementation of login page actually. He started working on implementation login page. On the same day, the user two, what she did basically, like she is implementing the implementation of home page actually, like this. Okay. So like that, they started working on the day one, and today is what is, guys? Today is day 17. It means almost 10 days. Today is the 10th day where they started working on, right? That is 17th November, right? And in today, what they were doing, right? Consider that the user one, right? Basically, he started added a login page with the Google actually. It means that with a Google account, you will be able to log in into that home page of that application. Assume that this is the feature which the user one has added. Similarly, the user two, right? What she did, she tried to fix some few issues actually. This is what she did in on day 10th. Assume that on the day 10th, all these days, all the code changes, what is it done by the developer and developer two. So this is the day one. Like that, we have a day two, day three, day four. Like that, you could see that today is a day 10th actually. So in between, there are many days are there where the developers worked on the same project. So every day they were trying to do some kind of a code changes. They were trying to do it, right? They're trying to add some code changes. They're trying to fix some issues. So a lot of multiple works were done by this both user one and user two, and it was working fine all these days. Whatever the code which they were developing, it was working fine. It means that they locally tested in their machine and they checked that okay, there's applications, whatever they are developing the code, it is working fine, right? On the 10th day, what happened, right? The user one, he tried to add this he did some code changes where you can able to log into the page with the help of a Google account. So he just added that feature actually on the day 10th, and assume that suddenly after he added this code changes, after he implemented code changes, assume that suddenly the application stopped working. The application stop working. Maybe there could be some kind of issue which has been done by the user one. By adding this feature, something, the mess happened, and suddenly what happened, the application stopped working, right? So it means that whatever the code changes he has done, right, that has actually breaked it. It breaked it in sense like that code, whatever he has added it, that is having some kind of an error or a bug. Due to that reason, what happened, the normal function about the login page is stopped working now. Now what we can do, guys, like basically we have did all these days, we have been developing from the day 1 to day 10, and suddenly the day 10th, what happened that because of this addition of this code changes, it stopped working. So what we do, that we will revert back to those changes which was last working, right? So it means that we'll revert back to the day 9th code where it was working fine. It means that basically we will remove this feature. So whatever the user one has developed it, we will remove this feature and check it out whether it's working fine or not. So it means that now when the user removes the code changes, whatever is done by the 10 on the day 10th, now we will see that okay, now the code is working fine. Now the application is working fine now. So it means that there was some issue which was been which was been added by the user one, due to which it is not working. Now the version control system, what happened, right? It maintains the history of the code changes what has been done by the user. It means that from the day one onwards till the day 10, all those 10 days, right, whatever the code changes we are doing, right, the version control system will maintain a history, will maintain all the code changes, so that what happened, that you will get to know what are the code changes which is done by the specific user on that particular day. So somebody has to maintain that history of code changes. So your version control system will maintain it actually. So why we need a history? Because tomorrow, in case if you do some, if you are messed up with something, you can revert back, or you can revert back, or you can rewind to your old code changes. Actually, you can go back to the old code changes, so that the whatever the application which was working right, it will start working fine actually. So that's the reason we maintain all this code, everything, into some centralized server, which we call as a version control system actually. Am I clear, sir? Right? So that's the reason we maintain it. So what this version control system do basically, guys, it will try to track changes to the files over the time, so that we revert. Revert means we can rewind to any past version, and also audit did the change, who who changed what. So it means that we can able to audit also, right? Because user one on the day 10th, he added this code changes, right? He implemented some addition code changes where you can able to log in, you can able to log in with the Google account also. So from there the things started. I mean, from there the things started failing actually. So we'll be able to easily audit actually. So that's the reason what happened, that we maintain this version control system. Am I clear, sir? Right? Okay. So this is what it is. Okay, good. Now, when we are learning the version control system, guys, we need to even come across with a lot of core concepts. We'll come across a lot of core concepts also. So what are those core concepts? So what are the core concepts? We will use some terminologies, right? Core concept, we will try to understand some terminologies. So over a period of time, we'll be under terminologies, right? One of the terminologies which we frequently always come across with the version control system is repositories actually. What is a repository is all about? So repository is something like, it is like a storage space actually. Basically we store some data, that is what we call the repository, but along with the storage we also maintain some kind of a versioning actually. So this is a storage place with versioning, right? With versioning. Am I clear, sir? So repository means it's a storage space. Suppose assume that you have a storage space and you are not maintaining any kind of a versioning at all. Then we don't say it as a repository. We just directly, or we just say it as a raw storage. That's all. Whenever there is a storage, along with when you maintain any kind of a versioning, or we call it history, then it means that that storage will not be called a storage. Now it becomes like a repository. So repository means storing the data and maintaining the history or maintaining the versioning also. We call it as a storage actually, right? Now, for example, assume that if I want to give you a classical example of what is a repo is all about, like Let me do one thing. Let me try to go into my Google Drive. So guys, we know that the Google provides you some storage. We call it Google Drive, right? I want to access the Google Drive. So what I'll do, I'll just say drive.google.com. So this is my drive actually, basically. Okay, this is my drive. And what I will do basically, guys, I will try to create some folder here. Let me create a folder. So I'll do a right click and I'll just try to create a new folder. Let me call it as a dummy. So I'll create a dummy folder here. Okay. So once you have this dummy folder, what I'll do, I will try to get inside the dummy folder and let me try to store some file here. So what I will do here, I will try to create one file here. So I'll just say something, hello.txt file. Okay. So this is my file which I want to upload into that folder actually, right? And now what I will do that I will just try to add some text here. Like I'll just say hello. Okay. I'll save this data. Okay. I'll save this data. Okay. I'll save this data. And what will happen that I will try to upload this data. I'll try to upload this file. So what I will do, I'll go over here. So I'll just say right click and do a file upload. So click on the file upload, go to the desktop, and you could see that actually this is hello.txt. So you could see that I'm uploading the data. So you could see that your file has been uploaded here, right? Now assume that I am doing further more changes into the file. Okay, I'll just say after this, I will try to say something like how are you? Something that now again I want to upload it actually. So now when I'm uploading that file, consider I'll upload the file. I'll just say file upload. Okay, I'll try to click on it, and if I upload the file, you could see that because it's a dummy storage, it's storage, right? Basically, it'll ask you whether you want to replace the existing file or keep both the files. So here what happened, right? When you try to replace this file, existing file, it means that it will just replace it and it will act like a storage only, right? Because in the storage, you're not maintaining any history, you're not maintaining any kind of a code change. So in that case, what happened, right? This storage is not at all not at all called as a repository because it is not maintaining any kind of a history or the versioning, right? Now, assume that actually you will say that Rajesh, I want to maintain the history here, so that whatever the code changes which I'm uploading it has to maintain the history of everything. Now, how to do it actually? How to do it? So now, guys, what you can do it actually basically, like you can able to open this file and the file information, and you could see that actually manage the versioning actually, right? Am I clear, sir? If you want to manage the versioning, you can go here and in the file information, you can manage the history. So when you click on the managing history, you could see that it is asking you to upload a new version. So let me do one thing, let me upload a new version now, right? Upload new version, click on it and then say open. So now you could see that actually guys, now you are having a current version which has both the changes. And now what happened, you are having one more older version which you call the version 1 that will maintain the last change what you did it actually. So now what happened, you are maintaining a history now, you are maintaining a versioning here. So now this is not called as a simple storage, you call it as a repository. So now you are making your Google Drive to act like a repository because here you are started maintaining the versions actually. Am I clear, sir? Right? Now you will say that, okay, Rajesh, let me do something, let me do some more changes. Okay, I am doing good. That file. Okay, again you will say that, okay, now you could see that. Now you started uploading. Now you could see that you have a current version now which has the latest changes, and also you could see that the previous version 2 and before that previous to that we have version 1. Now you could see that the version 1 was uploaded on 7:30 p.m. The version 2 was uploaded on 7:31 and the version latest version what we uploaded is at 7:32 p.m. actually. So here what happened guys, you are maintaining some kind of an history actually or some kind of a versioning over here, right? But you could also see that because since it's a Google Drive is not a completely, you cannot manage completely as a repository. Yeah, because you have this feature of versioning, that's what it is showing you. But you could see that it say that actually hello.txt may delete automatically after 30 days or after 100 versions are stored actually. So there are some limitations are there, but Google Drive doesn't no really used as a repository. Like I'm just for an example to show you I'm just showing you that how we can maintain the versioning actually. So this is what the versioning we need at the end of the day, right? And this is what something because the history actually which has to be managed actually. So that's what happened. All these version control softwares, right? Whatever we have VCS software, right? Or version control softwares will maintain the versioning, or it will maintain all kind of a history or changes whatever the user does it actually. Am I clear, sir? Right? Okay. Now, what are the different types of versions we have? Types of versions. Okay. Uh, this one, guys, this core concept I'll be keep adding on later. Okay. So let me type go version control system we have. So basically, broadly speaking, there are three types of version control systems are there. One we call the local, and the second is your centralized. The third is nothing but the distributed. These are the three version types actually, version control types actually. Am I clear, sir? Right? Local is something where you are locally managing it. Say, for example, the user one is managing the project local in his system, right? And he will be developing the whole code, right? All part of the code of the application is developing, and he's executing there itself. It means that he will try to take the whole code, he'll compile the whole code, he'll build a package, and he'll deploy it, and he will install it, he'll check it. So this is something where he's managing everything locally by his own. So this I would say that it is like a rare condition, a rare case where we don't really manage all the codes, everything in the same single local machine itself. That is not a correct way of doing things because it's not only this user is working on the project, there are multiple users are working on the project. And each one of us have to share their code actually, right? So it's not like that you will manage all the code in one local machine. No, you cannot do that, right? So this is not at all used in a practice in today's world, right? We don't use it, but earlier, very long back, yeah, people were managing everything in the local system, but those days are gone now. So it is rarely used, or almost I would say that it is not used nowadays actually. Okay, I could say that it is a rare or not used at all, right? This one, okay. And what is the local means? Basically, all the your history and repo is maintained and used on the same machine. Same machine means on your same local laptop. Okay, guys. Okay. So this is not used, guys. We don't use it this local versioning system. So the next is a centralized. So basically, what all the right this centralized, right? So basically, the type of version control system earlier, where we have something like a client and the server also, right? So client, what they do basically, right? They will try to log into this server, centralized server, and they'll try to do the code and see with the so it means that as soon as a user on user two, they log in on that day. It means that they try to come to office and they log in and they want to start working on the project. What they do instead of they maintaining all the code everything in the local laptop, what they will do, they'll try to connect to the centralized remote server, which we call the centralized version control system, and they will do all the code changes here only. So it means that you need to have some kind of a software where the client one or the user one can log in it. Similarly, the user 2 can log in it. If there are 100 users are there, all the 100 users will be trying to log into the same server and they'll be trying to do the code changes sitting onto the same server. So it means that you need to have some very good network. That is one thing, right? It means that you need to log into it and you need to start working on a project. Okay, that is first point. Second important point is that this server should be high configuration server because there are multiple users are there who are logging into this system. So it means that there has to be some kind of a server software should be installed and managed here. It means that server software means basically server software means what something like where you need to install some software where you manage the users actually manage the users accounts. Okay, manage user account. It means that basically you need to have all the user one, user two, up to what are the user number of users are there. You need to manage all their accounts here in the server, right? And also what happened, right? You need to make sure that whatever the connectivity is there, right? That should be always be available. Actually, connectivity should always be available. Basically, it means that suppose you are using some protocol like SSH protocol you're using to log in from user one to the server, or from user to this server, right? So there has to be always the network connectivity should always be available, right? If assume that due to some reason this server goes down actually, so it means that this users they cannot work on the project. They cannot work. They have to wait until the server comes up. It means that you need to manage. Somebody should be there to manage, to make sure that this server doesn't go down, and also they have to manage to make sure that all the users who are a part of the project, right, they should be able to authenticate to this server. They'll be able to log in and start working on the project. So you need to have a separate software for managing all those things actually. Okay, guys, this is something what we call it as a client and server architecture, where like a client can log into the server and he can start working on it. So that is what we call it as a centralized version control system actually. Okay, so if you ask me, Rajesh, do we still use it, the centralized control server version control system? I don't think so, guys, because most of the companies, 99% of the companies have migrated from the centralized to the distributed. Right? I don't see any companies are using centralized version control system, because it again has some disadvantages, right? Because basically each and one of the users have to log into the server, and you need to have a server side software. Similarly, on the client side, you need to have a client side softwares, right? Those client server software should be installed and everything, right? So many stuff have to be managed and maintained to make sure that you have the centralized version control system up and running. Okay, and there are many examples are there which comes under this centralized server version category. Okay, but I don't think see any companies are using in today's time. Okay, so under the centralized, what we say that one centralized server where client pushes and pull the changes actually, right? Right. This is what we call as a centralized actually, right? Now the point here is that actually that in the centralized software, what happened, right? Say for example, like a client one or the user one, he does some code changes, right? He will do the code changes and he will push the code changes into this repository, and that code changes will be available here. It will reflect here actually, right? It will be reflect here. It will reflect here, right? It will be reflecting here. Am I clear, sir? It will be reflecting here, right? Now the thing is that what happened, guys? Now here, user two, when he's working on the project, actually, user two, when they are working on a project, she might not see all the code changes what is done by the user one actually, because this server has all the code changes, all the codes what is done by the various different users, like user one, user two, user three. There are multiple users are there working on the same project. Each one of these users, what they do, that they try to do their code changes and they try to push into this server actually. And the server, in the remote server, it maintains all those changes what is done by various different users, right? But what happened, right? This is something like a server side where it will maintain all the code changes for the entire project. This is what we call the server view, right? Whereas the client view, or from the user perspective, whatever he is doing code changes, only that is available, right? Only he is able to manage that only, because only this code change what is done by the user one, this should be there in his local system, or he will be managing this one actually. Similarly, when she's working on a project, she might have did the code changes, right? She might did the code changes, right? She might did the code changes, and she might have her code, whatever she has developed, right? Only that part of the code she might have. And the same code, what she will do, that she will try to push that code changes into the server here. She will push the code changes to this remote server. Now, what I'm trying to tell here that, guys, so this server will maintain all the code changes done by the various different users. This is what we call it as a server view, server side view. Whereas the client side view, what happened, right? Whatever their individual code change, what they did, right? That only getting reflected on their side. Am I clear, sir? Am I clear, sir? So in that case, what we do basically, we will say that Rajesh, I want this code changes what is done by the other users actually. Then what happened? You need to fetch the code change. So the user two, if she wants all the code changes which is done by the developer one or the user one, right? She has to request that code changes. So what happens when she requests, when she pulls the code changes, that will come and sit here actually, right? right? And similarly, whatever the code change is done by the user 2, right? If the user 1 wants that one, he has to request to the server. So that change code changes will come and it will be fetched and it will come in his system, local system actually, right? So this is something what happened, right? Where what happened, each and every user will not be able to see the code changes which is done by the other user, right? It means that you don't have the same copy of the code everywhere, because the server is the one which maintains all the code changes, right? So client will have, or the user will have its own user view code, whatever they have did the changes, right? They'll not be able to see the other code changes. So whenever they want to see the other user code change, they need to request or they need to pull that code change actually. So this is what some kind of, I could say that, not like a disadvantage. It's something like where you'll have a server side view, right? The code changes, and the client side view code changes are there. This is what you will see in the centralized version control system. Am I clear, sir? Right? Now the thing is that now you said, okay, fine, I got it. What is the centralized code changes actually? Now the thing is that you will say that, Rajesh, when I am working on the project where whatever the code changes where the user one is doing, okay, the entire code changes should be there in the server side also, as well as the same code changes should always be even should be there even on the other user side also. Then in that case, how I can do it or how I can achieve it? So in that case, guys, you need to go with the third thing, which you call the distributed version control system. Under distributed version control system, everyone has a full history, and anyone can act as a server. Am I clear, sir? Everyone has a full history. It means that what are the code changes done by one user, the changes will be, you can able to get all the changes at the instance by the other user, as well as the same changes will be there even in the centralized server also, right? This is what we call it as a distributed system. Guys, just give me a minute. Somebody is continuously calling me. Okay, just give me a minute. Okay, guys, sorry, I got some call, guys. That's what. Okay. Am I clear, sir? So it means that basically what we do basically in the distributed side, what we do basically, guys, we will try to have a copy. Each one of us will have a same copy actually. It means that when the user one has a copy, the same copy, even the same copy will be there in the server side. The same copy should be there in the client side also. I mean, the other user also actually, right? But here, the thing is that in case of a distributed system also, where each one of us will have a same changes, whatever we did it, right? But in case of a distributed system, still we maintain one server. We'll call it as a main server where all the users, right, will try to push the code changes into the main server itself, right? But right, so in this main server, whatever the main server is there, here also what happened, you will have little bit extra configuration, server side configuration will be there, where you will manage some kind of a connectivity, will manage it, that is there. And also you'll also have some kind of a user account management also in this server, where this server manage all the user information, so that whatever the user who are working on the project, right, they'll try to do the code changes and they'll push into the code changes into this server, right? But this server side configuration, can the same server configuration can be achieved by the user one. Suppose that this user one who is managing, he is writing the all code. If you say that, Rajesh, can we make his laptop as a server itself? Yeah, in distributed system you can even make him as a main server also, because here what happened, in his laptop he has to install some softwares. What is that, we'll discuss later. he has to just add on some kind of a connectivity things and also manage all the user accounts, so that this server, now whatever the local laptop, this can also be called as a server itself, as a server, or as a distributed server. Same thing with the user too. But what I'm saying, that in distributed system, any one of the system you have to make it as a server actually, because that server will maintain all the code changes done by the various different users actually, right? Now, guys, what is happening is that actually, that in case of a centralized server, in case of a centralized version control system, okay, what we say that there is always a single source of truth, or the whole repo will be there in a single server, right? So in case centralized, only in one location you will have the whole code actually, the whole code, wherein what happened, the client one or the user one or user two, they have to get synced to the server to do the changes actually. So in case of a centralized, here what we say, that it is a single source of truth. It means that the whole repo have to be the server on the centralized server, and the client syncs with it actually, right? The client syncs with it. Am I clear, sir? Right? Now the thing is that, as I said earlier, right, if the server goes down, the entire team, the whole users will be blocked actually, right? So there will be some kind of an outage actually. Server outage happens, then it means that the entire team is blocked actually. This is a disadvantage actually, right? In case of a centralized machine, centralized server, right? Whereas in distributed system, what happened in distributed system, guys? Each each clone each clone has a full repo. It means that each one of us, each one of these users in a distributed system, they'll have a full copy of the same. Repo means what? It's a history plus metadata. Information means what? Three, right? Even plus, I can say that the entire repo actually, right? Repository or the code. This everything would be have a clone in each and every.
Rajesh, your voice is breaking. We can't able to hear you. Rajesh, can you hear me? Hello.
Can you able to hear me?
Yeah. Now it's audible, Rajesh.
Yeah, yeah. Did everyone face the same issue, guys? There you're not able to hear me.
Yes, sir. Now it is fine, but
Okay, but earlier, like, was there any voice drop?
yes, sir. There was a
Yes,
little voice.
Oh,
Rajesh.
okay, okay, sure, sure. Thank you. I mean, again, this issue has started coming, man. Okay. So now, so what I'm saying that, guys, like when it comes to distributed system, first locally the user will try to do the code changes. They'll try to do the code changes. Once this code change is done by the user, what they do, they basically push this code change to the to the remote server, some server where they maintain it, and from the same server, whatever the code are there, it get cloned to the all other users actually. So you can have the same copy of whatever is there in the server with the all other users actually. This is what we call it as a distributed system. This is what we call as a distributed system. So in distributed system, what they do better, like work is done locally, and later and later shared actually. Let us share to all users actually, all users and also into the remote server, right? And in case of distributed system, any user, like let it be user one or any user can act like a server, can act as a server actually. You can make any user as a server. Like as I said here, right? User one can act like a server. He can become like kind of a remote server, or he can become a distributed main server where all the code changes can be checked in here actually, right? Or else user two. Any user can become a server actually, right? Is it fine, sir? Okay. Now here you see that one more thing which I told earlier, that actually when it comes to centralized server, what we do basically, guys, we need to have a server where you need to have a server software to be installed here in the centralized server. Similarly, the client will have the client softwares actually, right? So what we say, client software is different from the server software actually, right? And all history, whatever you changes, it lives centrally in the same in one machine itself actually. So let me add on those points also here. All history lives centrally, right? And also client softwares is different is different from server software. So we need to even install or manage all those softwares actually, right? Right. And here what happened, right? In case of your this one, in case of your a distributed system, what distributed system will do that? Here everyone will have the same software installed. We don't need any server side software. You don't actually need it. We need to have the same software. Yeah, of course, if you want to make one server as a kind of a remote server, or you can consider it as a centralized server in distributed, then additionally you have to have to have some other softwares you need to manage, have it, so that you can manage the user accounts and the connected everything. You can manage it. And that is also quite very much quite simple when it comes to distributed system, right? So that is not that difficult actually. It is not that. Examples you have. Guys, can you able to hear me? I think there was a drop in the network actually.
No,
Yeah, now
Rajesh.
now it's okay, Rajesh.
Okay, okay. So yeah, thank you. And in the distributed system, like if you want to see the examples of distributed system, the examples are, what is it? It's a Git is one of it, and Mercurial, right? So guys, what we'll be learning as part of this course is a Git actually, right? And Git is what which is mostly widely used no version control systems. So many companies, right? Almost all companies, they started using Git. Of course, we have other things like Bitbucket is there, GitHub is there. We will discuss about those things later, right? So de facto is something like Git only today. So today, Git is a de facto. I can say that de facto standard, right? So hence we need to learn about the Git, and also we need to understand the whole working aspect of the Git actually, right? Clear, guys? Now, okay, that's okay. Now, the thing is that, guys, in this course, what I will be doing that I will be adding all the things, whatever it is there for the Git course, right? The content, what is there, right? I'll add everything Why? Because that like taking this Git again for all other subsequent batches or other upcoming batches, there is no use actually, because you need to explain the same thing again. So what I thought that for this batch, for your batch, I'm going to add everything. I'm going to like the whole content on the Git, I will add it, so that I don't want to really repeat the same thing taking classes, right? Next batch and all, what I will do basically, I will try to share the same video to them so that they'll be able to watch it actually, right? And Git, usually what happened, guys, there's not much changes happens in the Git, so there is no point in taking the class again for the Git actually. That's what I thought. There are some topics are there like that. For example, Docker is there. Docker also for your batch, I will take the complete Docker end to end. I will take, so that for the upcoming batch people, right, I will share the same Docker. Later, if there is any kind of enhancement happen, if there is any changes happen, right, only those part of only I will take the videos. I'll record the videos. Like for example, for you all, as I said, right, advanced Jenkins I will take, but already I have shared you the previous batch video, right? So you can just go through it and complete that. Once after you complete, right, I will, when I take the advanced one, then you'll be able to quickly you'll be able to sync up and you'll be able to understand what I'm explaining in the advanced level, right? So there are some topics are there, guys. Some tools are there, like Docker is there, Git is there, Ansible is there. I don't think that we need to take in every batch again. It is not really required. If you have one solid, complete video set, right, end-to-end video set we have, right, we'll be able to learn it. And usually this changes, this code, this tools and all will not change drastically. Actually, they won't change. Only some add-on feature they will do every time whenever they want to add it, right? So those things and all, yeah, we can say take a separate classes for that. But yeah, that's what I thought, that this three to four important tools what we have, right? Like Git is there, Docker is there, Ansible is there. This I won't repeat again. We will have a cut short, whichever is most important thing for a DevOps or DevSecOps or for the platform engineering to learn, right? Only those things only I thought I will take class. Like for example, GitHub Actions, yeah, you need to again take it, right? Apart from that, is there any other thing like, yeah, Azure DevOps is there? Yeah, that we have to take it. And Kubernetes, of course, for every batch I have to take Kubernetes classes, because Kubernetes is something where everyone have to learn from the very scratch onwards. You have to learn it actually, right? Yeah, cloud is also something where, guys, like yeah, you can learn one time, and only some important topics only what happened that I have to take class. Remaining and all, yeah, you can give the videos, the people can learn it actually. So it's not really required. And nowadays you have seen that many organizations what they do, that they don't really take sessions every time. They have a solid video recording, they'll do it actually, and they'll distribute that to the people actually. People go and watch those videos actually. So yeah, this is what I thought. Like, let me for your batch, I'll try to cover as much as possible in these topics, so that the next subsequent batches I will not repeat it. I will not take the classes. Hardly some few sessions I will take class, and then I'll say that okay, guys, watch these videos, take your time, watch these videos, and then like complete it. The way I did for the Jenkins, right? Similarly, I'll give you the Ansible videos also. I'll ask you to go through all the videos, and then like at the advanced level of Ansible, yeah, there I will take it actually, so that you will be able to understand all the advanced topic on Ansible, right? Fine, guys. Okay, good. Now, so let us try to understand about what is this Git tool is all about. So we'll start our journey in Git actually. So let us try to see. So first, let us see some history behind what is a Git all about. Who designed this history? Sorry, who designed this? What do you call? Who designed this Git actually? Right. So if you go to the Wikipedia on Git actually. So you could see that, guys, Git is a distribution. It says that distributed version control system, right? Yeah, you could see that it is a distributed version control system, and it is capable of managing versions of the source code of the data. Who designed this? It is designed by the Linus Torvalds actually. So Linus Torvalds is the same person who designed the Linux kernel, right? The whole Linux kernel or the Linux operating system was designed by Linus Torvalds. The same person, he designed even this Git tool also, right? So as we know that Linux is an open source actually. Linux is an open source. So Linux is a open source community project. So what happened earlier, guys, to manage this whole Linux kernel code actually. So what the Linux community did, like what like Linus Torvalds and his teammate they did, right? They maintain all the Linux source code in one of the version control system which they call as a bit keeper actually. Okay, they manage all the code under the BitKeeper. BitKeeper is also one of the source code versioning tool actually. Later, what happened, right? This BitKeeper tool, right? It was no longer free version. They made it as a paid version actually. They made it a paid version so that you need to pay the money for you to manage your code under that tool actually. So then later, what Linus Torvalds thought that actually, why you have to pay the money to maintain my Linux source code under the BitKeeper. So then what happened that he thought that instead of going with some other tool where again he might have found many other tool like Mercury tool was there where you can manage all the code under the Mercury tool. But again what happened, who knows, tomorrow Mercury tool might make as a paid version, right? So again you cannot really go and move your code from one version tool to another version tool like that. You can't maintain it or you cannot do all those activity. Hence what Linus Torvalds thought that let me design my own tool actually. Let me design my own versioning control tool. So that's the reason what happened that he designed this Git tool actually. He designed this Git tool actually. So this Git is actually developed by Linus Torvalds. He's the one who developed it and he made it. He developed it under the open source project actually, under the free open source project. Clear, guys? Okay. Right. So now here what happened, right? Like since as I said, right, Git version control system or the Git tool, what happened, it maintains the same copy of the data in all the systems wherever you are working. So if all the systems, let it be a client machine or let it be server side machines, so you will maintain the same copy of the data you will be managing in everywhere. This is what the core concept of core working of the Git actually. That's what we call it as a distributed system. Distributed system means the same copy will be there in everywhere under this distributed systems actually. So what I say that in case of a Git actually, we say that actually the core working of Git is all about understanding understanding to maintain the same code across all distributed systems actually. That is the core concept actually, right? That is what distributed system is all about actually. Am I clear, sir? So let us try to understand what is this Git is all about, right? How do you maintain the Git everything? So basically, guys, today I said that I will be taking for only 1 hour every day. Since like I spend some 2-3 minutes right later, let me continue for 2-3 minutes so that I'll be completing certain things. Okay. Okay. So basically, what happened, right? Git has 5 stages actually. Git has 5 stages. What are those stages actually? So the first stage is nothing but the working tree. The second stage we call it as a staging area, and the third we call it as a local repo. The fourth one we call it as a remote actually, remote repo or just a remote, and the fifth we call it as a stash. Okay, we are not really worried about the stats as of now. Okay, we will try to learn about this fifth stage of the stats later, not now. But we need to really worry about this the 4 stages like working tree, staging area, local repo, and remote repo. Right. So these are the 5 stages, but we are considering only 4 stages as of now. Stash is something we will discuss at the nth class, nth moment, right? When you are about to wind up the Git, right? At that time, I will tell about the stats. It is not really that much relevant as of now, but still, okay, that is one of the other stage. What is there, we call the stats actually, right? So now, if you try to go with the diagram, right? So you can just consider that this is nothing but your working area actually, working tree actually. Okay, let me do one thing. Let me take a, yeah. So these are the 4 stages, guys. Okay, this we call it as a working tree. This is what we call the staging area. This is what we call it as a local repo. And this we call it as a remote repo or just a remote. Or you can even call it as a remote repo. And if you ask me, Rajesh, these are the 5 stages of the Git actually, right? Right, 5 stages of this Git. Where exactly this Git stages comes in, right? For example, like the working tree staging area and the local repo, where this stage, all these 3 stages comes. So guys, this 3 stages comes in your local laptop only. Say for example, wherever you are managing the code, like for example, here the user one, he's sitting in his folder project A and he's doing the code changes. So Rajesh, when it comes to the Git, right, under the project A folder, does all these 3 stages, working area, staging, working tree, staging area, and local repo, all these 3 stages comes under this project A folder itself? Yes, sir, it comes under the project A folder, and this project A folder it is in his local laptop only. Okay. What about this remote repo? Remote repo is something where you are managing some server as a remote server. There you will maintain the remote repo. So this 4th stage, which will be part of the remote server. But whereas these 3 stages will be part of your local server only, or your local laptop, where you will be managing all your code in some folder actually. Am I clear, sir? So that's the reason what happened, right? I will try to take a diagram of your laptop itself. Right, I will just say that, okay, Rajesh, this one, this the other, this one, you will say that, Rajesh, this is there here in the working tree, as well as this staging, it also is a part of your laptop or your local system. Even the local repo is also a part of your system. Am I clear, sir? Right, this comes under your local laptop only, all these 3 stages actually. Right. And what about the remote server? Remote server is something where you are managing some centralized server actually. Right. So this is something here remote. Am I clear, sir? Now, whenever a user try to write any code, when you start writing the code in a folder, actually, initially what happened, he'll be sitting and he'll be writing code. That is what we call as a working tree. Once he completes the code, actually, basically, like, you need to push that code changes into the staging area. Actually, you have to push the code changes to the staging area. Once you push the code to staging area, later you want to push that into a local repo, which we call it as a commit. Okay, that we call as a commit. So you have to commit into the local repo. Once the commit is done, like later, if you want to do the code changes or push the code change to the remote, you need to basically do a push operation into your remote repo. Right. Late after that, if you want to pull it, basically you can even pull it also from the same remote repo. You can even pull the code actually to pull the code from the remote repo. Right. So these are the 4 stages what we have actually. Right. Apart from this, as I said, right, you have one more stage, right? Stage actually, which we call it as a stage actually. But right now, I'm not really worried about that stage actually. Right. I'm not really worried about the stage. I'm not really worried about the stage. But yeah, of course, we have the stage area also. Right? We have a stage area also. This we call a stage. The stats is also like it is a part of your local system only. That's what you, whatever the stats you maintain, right? That will be in your local system, local laptop only. That's what I'll be mentioning over here actually, right? And how it happens basically, like when you're working on something, certain code in a working tree, you want to push that code and what you did into the stat, you can do it actually like this to the stat area. So this is something, guys, which we'll be discussing not now. At very later stage, we'll be discussing about the 5th stage. We call it stats. Am I clear, sir? Am I clear, sir? So are you okay till here, guys? Any questions so far?
No,
No,
Rajesh.
Rajesh.
Okay. Should I continue or should we stop it now? Because I committed that I will take for 1 hour. So it is, yeah. I love to continue, but yeah, because of some, like because of one of the comment, right, which I got from one of the participant, right? That's what I'm restricted myself to just hold on for only 1 hour. But I love to continue because I have to cover many things actually. Fine. So let me do one thing. Let us stop itself. So we will try to fix with the 1 hour session only. Okay. And okay, let us stop today's session now. Okay. So we will try to continue from tomorrow again. Okay. So guys, okay, before we wind up today's session, guys, like I want to just announce one thing. You might have seen my WhatsApp messages, right? Like basically, I'm very much willing to start the AWS class actually. Okay, AWS Cloud class. Okay, and we don't have any other time, guys, because evening we are taking Git session. So let it go parallelly. So Git, it will, if we are, if I'm fixing for 1 hour session every day, assume that actually, so I can easily say that this session will go up to 15 hours. Actually, 15 days it will go actually. 2 weeks it will go. So if I start it today, right, it will take another 15 more days to complete this Git actually. If I would have did like 1.5 or 2 hours, I would have completed it in 10 days or 11 days. But anyhow, that's fine. We will go up to 15th day, right? And then as I discussed that once the Git completes, like basically I will start with the Docker actually. Okay. And guys, as I said, right, all these classes will be there every day. We don't have any break now. Every day, Monday to Sunday, like all 7 days of a week, we'll have the sessions actually. But I was just thinking, guys, to speed up our taking sessions and everything, right? I thought that I will start with the AWS also very soon, like probably from Wednesday onwards, from 19th onwards, I'll start taking the AWS actually. Okay, 19th. So AWS, we know that it is one of the one of the cloud what we'll be learning in this course actually, and AWS is a very big topic, guys, because if I want to really make you understand like how much time it might take for us to complete the whole AWS, it would easily take like 3 to 4 months of time. Aram se it will take. Even though if I take every day 1 hour, next to 4 months it will take me to complete the whole thing actually, right? So, but how we are going to, yeah, Rajiv, right? Yeah. Let it go in the recording, Rajiv, so that the people who have missed, right, let people who have not joined, right, even they'll be able to like uh, hear this whatever I said. Okay, so now what I'll be doing, guys, like AWS, that's what I discussed with Rajiv. So he's okay with this because he can attend the morning class. Only I need a confirmation from Pankaj because Pankaj also want to attend this AWS. Of course, obviously all our participants they want to attend it actually. So what I was thinking, guys, I will take like every AWS class I will take for 1 hour 15 minute session. I will not go beyond this. Each session I will take like this, and I will be starting on Wednesday onwards. That is 19th onwards. I'll start. Okay, and timing what I like fix that I will be starting timing at morning 8:15 a.m. IST. So 8:15 to 9:45, 8:15 to 9:50, 9:30 till 9:30 a.m. IST. I will take the class. 1 hour 15 minutes. I will take every day class. I will take every day, like every day, Monday to Sunday. I will take every day so that I will not miss this at all. So where I'll be starting, like how I'm going to start means basically initially I will give some introduction to the cloud computing, introduction to the cloud computing all about. Okay, what is this, what are the different types of cloud like cloud providers we have, what is public cloud, what is private cloud, all those basic thing. What about the cloud infrastructure, what about the region, all about that itself will take around like 3 to 4 sessions it will take actually, right? This is all basic things about the about us to learn understand about the cloud computing, particularly AWS, right? And later what I will do that I will start with the first service which we are going to discuss is AWS networking actually. So this will take around 15 days of time to complete actually. Okay, so I will not directly start with AWS networking. Initially, I'll go with introduction to the networking. What are the different types of network we have? What is public network? What is private network? What is like different classes of IP address? What is subnetting? These are some basic things, guys, which I'll be taking like 2, 3 sessions. Basic of networking I'll take. After that, I will deep dive into the AWS networking actually. AWS networking is an elaborative topic actually. That's what I want to first attack making us to learn AWS networking first itself. Actually, I could have took EC2 compute, or else I would have took some other thing, but I don't want to really take that. First, let us attack on networking part, finish in a very fruitful way, so that each one of us will be having very in-depth knowledge on AWS networking part. And once we are strong with AWS networking part, then I would say that guys, you can learn any other topic very easily. You take any topic, you take a IAM user, you can take a compute, you can take a S3 storage, everything. So those things and all, aram se we can take the class. So you could see that if I try to take from Wednesday onwards, you'll see that in next 2 months, guys, we would have completed the AWS networking, IAM service would have completed, EC2 also would have completed, and even the S3 bucket also would have completed. Storage also would have completed. I think in 2 months we would have completed we would have completed minimum some 4 to 5 services actually, and that is very good for all of us. If we have completed 4 to 5 sessions, very good, perfect. In 2 months we will have completed many things. After 2 months, you could see that I'll be covering many other services like Route 53. I'll be covering. I'll be covering about the serverless services like Elastic Stack Bean, for example Lambda, everything. Right afterwards, I'll be taking about the security. I'll be taking about the AWS development tool actually. I'll be taking about the some of the data analytics tools actually. I'll be taking about lot of other topics are there, guys, which I'll be slowly covering one by one actually. So that in the next 4 months, you will see that you would have completed the whole AWS in a very fruitful way. And each and every topic, what I will do, even for the Git actually, even for the Linux, I have to cover. I will see when I will cover each and every topic. Once I complete the whole content on the particular, say for example, after completing AWS networking, I will the last 1 or 2 sessions. What we'll do, we'll have a doubt session, and also we will try to keep the all important intro question answers, whatever it has been asked on the AWS networking part. I'm going to cover those things also very well, so that we will be able to understand. And also I will see that whether is there any chances that I can take a project, try to take a project and explain you in the project level also. See, in the project wise, what happened, right? You will be collectively, you'll be able to do the project related things and all when we know the DevOps tools and when we know the cloud actually. If you ask that, Rajesh, can you explain me the only project related to AWS networking? You can do it, but you'll not be able to, full fledged, you'll not be able to connect it, because yeah, networking, you can say, for example, you say that, Rajesh, how to create a VPC, how to create how to do a VPC pairing. These are concepts only. You'll be learning and you will be doing practically, right? But when it comes to something like where you say that, Rajesh, I want to implement the three-tier architecture. Okay. In that case, what happened, right? You'll come across the AWS networking, you'll come across with something like a security group, you'll come across with something like a route table, you'll come across something like internet gateway. Lot of services you'll be using for creating the three-tier architecture. You should also learn about, like, in three-tier architecture, how do you maintain it. So it means that all the three-tier architecture you have to maintain the private subnet. Okay, fine. And after that, what happened, right? You have a website or web server. You'll be having application server. You'll be having data server, right? You have to come across with that of creating these instances, right, in this private subnet, and then, like, showing the entire flow of it. And actually from the outside, if you want to connect to the application which is running, right, then you need to come with the load balancer, you need to come with the DNS actually, you need to come with the route 53, which is the DNS. So all that components and the load, you have to do it actually. So it is a combination of many technologies, plus it also combination of many of the other DevOps tools actually. So unless and until I don't cover few of the DevOps tool, right, I cannot really show this integration part and show you as a project actually. Of course, it is quite interesting to show all these things, but, like, let me cover some few ample tools in DevOps, and let me cover some few services in AWS. Once we have covered few things, then only I'll be able to show you clearly on the project side actually. Project side, you don't worry, guys. I'm going to cover more than 10-15 projects in this course, so that you guys can practice the whole project, and you can even execute also. Okay, you can do the project by your own also. Once I complete the project, I will request you to do the same project, right, by yourself, so that you'll get a confidence actually. Am I clear, sir? So every topic, what I thought that I will cover the question answers, everything, and important like bullet points also I will try to cover when I complete it. So let me first complete the AWS networking, guys. That is a core concept. Once that is completed, the next topic which I'll be attacking is AWS IAM user. That again will take around 8 to 10 sessions it will take me to complete it. After IAM users, I will take the EC2 compute. EC2 compute again 10 to 12 sessions. Storage again 10 to 12 sessions. So it is a quite a big course actually, the AWS. So when I start now, like slowly we'll go through it. So guys, now this is what the timing it. I am not sure like how many are comfortable with this timing, because this is the only time I'm able to get it actually. Okay, I'm not sure like how many would be attending. I don't know what your timings are, but I feel like okay, now I have to start this one so that we are parallelly learning the DevOps tool as well as parallelly even our cloud class is also going on actually. Right, that's what I thought. This thought is coming from last 2 days. That's what I thought I will discuss with you all. So guys, let me know your opinion. I know some of you might not agree with this. They might say that, sir, we don't have time to attend for this and all. So somehow you have to manage. You have to go through it actually. That's the reason. What I thought that let me keep a short duration of like 1 hour, 10 minutes or 1 hour class, so that if you guys missing the videos, you say missing the class, quickly can go through the video and try to learn, and then like quickly you connect with me if you have any doubts and all. So that in that way also you can learn it. I'm not saying that you can't learn through video. You can learn it, but try to see that if you're able to attend this session. Try to see, try to make some time. Please attend this session and help me to complete this course actually. Krishna, I think you said okay for this. Naveen, I'm not sure. Ayo, I don't know. Dipali also, I don't know what you guys are thinking about this.
Uh, Sorry, can I talk?
Yeah, yeah, please go ahead, sir.
Okay, this Ayo here. Okay, so I think we can go ahead because we have so much to cover,
Yes.
and the reason is because we are really going in depth. You know,
Hmm.
courses that I've taken some courses in time past. In 1 hour, some people are done explaining some of these concepts, but you go more in depth. So I think we should, go with this class. If we miss any of the classes, we can listen to the recordings and then come back to ask questions where applicable or where necessary.
Right,
Thank you
right.
very much.
Sure. So, guys, one thing I want to tell you, like, yeah, I'm covering all these things. Now, whenever in the group, in the WhatsApp group, if I say that, guys, today I'm going to take this project, right? For that, right, don't miss the class on that day. I would seriously request everyone that, and definitely you will see that in some time I'll say that you will see, I'll start seeing, I'm sending message, guys, today I'm going to take this project. This project will take 1.5 or 2 hour class. Okay, then you guys somehow you try to make and you try to attend that core class. Actually, see what is the project execution is all. Once you see the project, firstly, the two things are the one is that you will get to know like what are the tools I'll be using for to execute the project. That is one thing. Second, what is the project is all about? What kind of a project? What kind of a application I'm using? Either I might be using Java or either I might be using Node.js or .NET based application. Yeah, you'll get to know what type of application Rajesh is trying to deploy it or he's trying to use in his project. And the third important is that what integration part, integrating all these tools okay along with the cloud and everything, and also you'll see that there are some other external tools are there which I'll be using in the project, like I might be using HashiCorp Vault tool actually, okay, in our project actually. So what I will do that I will try to give a brief description about what project I'm executing in the WhatsApp group itself. I'll send that, and also what tools I'll be using. So once you get to know, okay, Rajesh is doing something today, he's explaining the project today for 2 hours now, and it's not like that I will take very early morning those projects related and all. I will take according to convenience so that you people have to attend that class. And whatever the project I do, right, same project you need to do by your own. It means that once I execute the project, you now it's your turn. You have to execute your project, the same project. For that, you should have some knowledge. I'm not saying that you should have full-fledged knowledge. No. Suppose, for example, if I'm taking something like related to the pipeline, I might use the Jenkins. So I might not really expect that you all have to know Jenkins, right? But still some basic knowledge, because I've already shared some videos, guys. Like go through that whenever you have time. And then like once I start taking a project, you'll be able to sync it. Okay, Rajesh is installing Jenkins. Okay, these are all the plugins he's installing. Okay, these are the environment setting he's doing. You will get to know many things when I'm explaining in the flow in the project, right? About when it comes to Jenkins. Similarly, Docker, when I'm taking any of Docker, I'll cover. Docker, I'll be using to build a Docker file, how to build a Docker file, what's a build a command for Docker, how to push the Docker image into the Docker registry, private registry. All these things I would have covered it, but when it comes to a project, I'll be showing every bits and pieces of everything, how to configure and how to do it, and finally how to integrate the whole thing. So that these three important part, one is that application point of view, what application you are using. That is one thing. Like either it's a Java, Node.js, Python, or else it is .NET, right? That is first point. Second point is that what is the build tool he's using, Rajesh is using to build all these applications, right? That is the second point. The third point is that, okay, which is the CI/CD pipeline he's using, whether he's using Jenkins or whether he's using GitHub Actions. Okay, he's using Git. Okay, Git, I'm aware of what is Git is all about. And then like, what are the other tools he's using? Okay, Rajesh is using Nexus, Rajesh is using SonarCube, Rajesh is using some security tools. Okay, Rajesh is using some Docker tool. He's also deploying the whole code into the some EC2 server by using Ansible, or else he might be deploying into some EKS cluster. So I'll be showing how to create a EKS cluster, right? How to manage everything and how to push the changes, code changes, whatever you build to the EKS cluster with the help of a Jenkins or with the help of a GitHub Actions pipeline. So when you see the whole project flow, guys, you'll be able to understand like how he has integrated the whole stuff actually. This is what I need. At the end, what I need you to learn is that, okay, how we are integrating all these tools to execute the project. We need to understand that flow, the same integration they are going to ask in interview. This is what I need from all of you. And if you see the same, it's not like that I will do only one project, guys. Same similar project, repeatedly, same thing I'll be doing, same integration I'll be doing, same thing. So that you will get used to by seeing the same thing again, again. You might something, you'll feel headache. What is Rajesh explaining? Same thing again, every project. It is good that we listen to the same thing again. When you try to see same thing again, you understand, okay, this integration is why seeing the same thing repeated, guys, what happened, right? You will be used to that actually. Oh, you'll understand, okay, this is simple, man. Every many times I've seen Rajesh what he's doing. So even when you are doing that, you will not do any mistake. You'll be very much confident when you are trying to do that integration part. And that is what I need. You should feel very much easier, comfortable for the integration part. Once you overcome from that, right, then I said, okay, now you have become perfect now in DevOps and cloud, and now you can able to quickly learn whatever you want to learn in the future, right? Any higher concept when you want to learn it, you'll be able to learn in a very faster pace. This is what I need from you all, right? So guys, yeah, Ayo has given his okay, go ahead, okay, for the AWS class. I am not sure about Deepali, Himanshu, Krishna. He said he's going to attend. He said, Naveen, what about you, Naveen?
Yeah, it's okay for me, Rajesh.
Please, Naveen, and see, I will tell you one thing very frankly, guys. Not everyone are attending. I know some people who are having time, they
Uh,
attended. Some
Rajesh,
people
can you hear
don't.
me?
Yes, I'm here. I can hear you, Naveen.
Yeah, I said okay, Rajesh. It's fine for me.
Yeah. Thank you. Thanks for that. What I'm saying, Naveen, like I know some of you are regularly attenders. Some people are not able to regularly attend. I know you might be having work and all. I understand your things. I'm not forcing anyone to attend every day. I'm not saying that. I understand that. But I'm also very much thankful that some people are regularly attending. Because of them, I'm able to take the class. So I need at least some ample number of people to attend. Like one is a Krishna who's always attending. Thanks for that, Krishna. Like you are regularly attending, and even Rajiv is there, Pankaj is there, right, from Japan. They are attending it. No, you guys are like really helping me a lot because you are attending and you are listening to the class. So I'm thankful for that. Similarly, like for AWS class, when I'm taking the morning batch, right, I need at least few people to attend, right? It's not like that no one is attending. Like I'll not be able to take the class in that way, right? Yeah, thank you, Dipali. So Dipali has also confirmed that she's going to attend. Thanks, Dipali, for that. Yeah, definitely, because if you give me moral support, right, definitely I'll be able to do all this session in a very fruitful way. Okay. So with that, guys, I think I'll stop it. I will not take any much time of yours. Okay, with that, so guys, from 19th onwards, right, we'll do a Sri Ganesh. Sri Ganesh means we'll start with our AWS class. Is it fine? And tomorrow again, same timing evening, we'll continue with the Git actually tomorrow. Git a day, 5 session will take it. Hmm? Thank you then, guys. Let me stop my recording. Let me
Okay,
stop the recording.
thank you.
Yeah, let me stop the recording.